Welcome to Bidnik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask questions and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Basic tutors. Excellence is our watchword.
Let's start with a velocity time graph of a car that starts with an initial velocity of 15 km per hour and acceleration of 5 meters per second. So just as we said, solution, we'll be looking at the stages. So let's start with the stage. A velocity time graph of a car which starts with an initial velocity. That means no address there. That's an initial velocity of 15 km per hour. We have U1 is 15 for the first stage. A there. We have U1 as 15 km per hour. So if U1 is 15 km per hour and our acceleration A1 is 5 meter per second square, then our V1 is 30 km per hour. So what we want to deal with majorly now is the conversion of our initial velocity and final velocity to meter per second. So that's our major concern now. So we'll convert that. Will be here and here. We should not forget this. Our T naught is 0 seconds. So our T1 is what we are looking for. So before we do that, our T naught is 0. So the T1 is what we are looking for. Let's look at that before we do the total distance covered. Let's look at our U1, which is 15 km per hour So the U1 will now be 15 times 1000 because this is 15 km per 1 hour. This means 15 km per 1 hour. So we'll convert the distance to meter, the hour to seconds. So because 15 km per hour means 15 km per 1 hour. So this will be 15 times 1000 conversion to meter. Then that 1 hour will be converted to seconds. That's 1 times 60, which is minute times 60. So we'll do that. From that we have our U meter per second, 4.2 meter per second. The same thing for final velocity. That will be 30 km per hour. So here V1 will just be 30 times 1000 over 60, 1 times 60 times 60. So times 60 times 60. So clean this up. V1 is 13.9 meter per second. So that's settled. So from the question we are told to find, let's draw the velocity time graph first. After then, I want us to draw the velocity time graph. Velocity time graph for the question. So then we can keep our work going. T seconds. velocity meter per second. So since we were told from the question, we were told that the velocity tangle of a car start with an initial velocity 15 km per hour. So since we started with initial velocity, it can't start from here. It has to start from somewhere here. Okay. So it will now be move up like this level. So this is my T naught, which is 0 seconds. So here the acceleration is 5 meter per second square. Then the initial velocity given to us, is now, before it's 15 kilometer per hour. After then, it goes up like that. We have my T1. So they said, then accelerate uniform, okay, until attain maximum velocity of 30 kilometers. So this is 30. From our work here now, we discover that we trace this up 3 meter per second. So this is 30 kilometer per hour. So this is my V1. So move to that. This is 5. So it maintains this speed, minimum velocity of 30 km per hour. It maintains this speed for the next 2 minutes. So here is, we don't know the value of this, but they said it's for the next 2 minutes. So let's draw this out. Next 2 minutes. So in calculating this, we discover that from here now, we discover that our V1 is 13.9 meter per second. So with the initial calculation we had there. So let's proceed with our work. So with our work here, we know that acceleration is equal to V1 minus V1 over T1 minus T naught. So if our acceleration is 5, my final velocity is 13.9, my initial velocity is 4.2 over, here will now be T1 minus 0. So we'll be calculating this. Let me get my calculator. From here now, we can now say 13.9 minus 4.2. That will now be 5. 5 is equal to 9.7 over T1 minus 0. So here will now be 5 open bracket T1 minus 0 is equal to 9.7, which is 5T1 minus 0 after 0 is equal to 9.7. So 5T1 is 9.7. 0 plus this still remain as 2. Double side by 5 by 5. So T1 is equal to 9.7 divided by 5. That's 1.94. That's 1.94 seconds. So that can approximate it to 2.0 seconds, just to make it more efficient. So that means here 2.0 seconds. So that means our T1 is 2 seconds. Then our T2, we were told from the question, we were told that it maintained this speed for the next 120 seconds or 2 minutes. So since it maintained the speed for the next 2 minutes, so we add 120 to this. So here T2 will be 120 seconds. So that's settled. I'm sure that's clear. So we are now told to find the total distance covered before its maximum velocity. So we have the first stage, this is the first stage, this is the second stage. So A, B, C, D, G, D, E, this F. So we are told to find the total distance covered. Find the total distance covered before it maintains before the maximum velocity. So the total distance covered before its maximum velocity. That's the major aim now. So So let's do our work. I'm sure this is clear. So TDT for maximum velocity. Total distance cover before it will maintain the maximum velocity if the distance cover of the first stage So that will be the major thing you need to take note of there. So let's look at this. This is like a trapezium. This is the longer distance. This is the shorter distance. This will be my height. That's the shape of a trapezium. This is the longer distance. This is the shorter distance. This will be my height. So here is equal to half open bracket. Then here will be BE plus AF. My height will be FE. So that will be half open bracket. My BC, that should be 13.9. My BE, that should will not be 13.9 plus my AF 4.2, the FE 2. So that will be F times 2 times 13.9 plus 4.2. 13.9 plus 4.2. That will be 18.1. 18.1. So that distance will be 18.1 meter. 18.1 meter. So plus 2 will cancel this. 18.1. So how do we come about this? The total length here is BE is 13.9. 13.9. The total length FE is 4.2. So the height. This is the height. The height. 2. This is the height. So FE is 2. So 13.9 plus 4.2 is 18.1. Then the 2 I brought here. 2 cancel here 1. Here is 1. So I have 80.1 meter. So that's settled. So if that is settled, let's look at the total distance covered in the entire journey. So the total distance covered in the entire journey is very simple. We've calculated this one already. So we want to calculate this. And that's all. So total distance covered TDT. So we just let me do the distance covered at the second journey. So I have my BC times, it has the shape of a rectangle. So BC times BE, depends on what you want, either BE, CD, ED, anyone. You can use ED multiplied by CD or ED multiplied by BE. You can use BC multiplied by BE or BC multiplied by CD. Just normal length times breadth. So my BE, my BC, according to what we have here, we have 2 here. Sorry? Oh, since they said 2 minutes, here we want 22. Please, a mistake. 22 seconds, because it will be added to this. It's always added as far as time is concerned. The 2 seconds is added to 0 seconds there. The 2 seconds is added, making this 2 seconds. 120 is added, making this 122. So if that is done, we can now move. That is done. We move. We can now move. So we say this is 13.9. 13.9. BC is 13.9 multiplied by, that should be 120. 13.9 multiplied by 120. We have 13.9 divided by 120. That's 1000. That's 1668. 1668 meter. So from here, we can now say the total distance travel will now be dt1, the first one, plus dt2, the second one. So here is 18.1 plus 1668 plus 18.1 meter. So the average velocity here, 3. The average velocity here will be v plus u over 2, which is 13.9 plus 4.2 over 2. That's 13.9 plus 4.2. 13.9 plus 4.2. That should be 18.1. 18.1 divided by 2. That should be 18.1 divided by 2. That would be 9.05 meter per second. So that would be the average velocity. So that's all as regard the topic. Thank you. God bless you. So we'll still continue from the continuation of the motion of velocity time graph. We'll still continue from the velocity time graph as we proceed ahead. There are still more past questions to still solve. So we'll just go from there. We'll move to motion under gravity projectile. So we trust God for more clarity. We trust God. We are sorry for the time we've not been able to come online like that. Though my wife has been cultural in YouTube. A lot of other jobs we need to attend to, but we can assure you this time around we will have more time together. Okay. We'll have more time together. We promise you. You know, most likely we might be releasing video every 2 to 2 days. So thank you. God bless.